To begin, we should start with the first, but most important and most frequently overlooked aspect of any sort of statistical analysis, and that is having a properly identified research question. This is critical because it's going to lead to you selecting the, well, quote, relevant and theoretically correct variables, and it's going to inform what statistical methods you're going to end up using. I'd like to start by highlighting an example in which we're interested in whether or not an employer is discriminating against female employees. And we have data from that company on salary, the employee's qualification, the employee's gender, and we have a host of questions that we may be interested in asking, but we need to narrow in on one of them. So, for example, we may be interested in, on average, are women paid less than equally qualified men? Or we might be interested, on average, are women more qualified than equally paid men? Though subtle, it is going to change the way in which we analyze our data. Now that we have our research question in hand, we can go ahead and select the relevant variables that we're going to use in our regression analysis. This should be informed solely based on whatever research and theory that is guiding you within the field that you're interested in. You need to think about a host of different explanatory variables that could help explain or predict some outcome or response variable that you're interested in. Once you have that set of relevant predictors as well as the outcome, you can go ahead and collect that data. We're going to talk about different types of data collection throughout the semester. So this could be from an observational study that has already been conducted, or this could be from an experiment that you are designing yourself in which there is some sort of treatment or condition that is randomized among participants. And this is going to change the potential inferences that we can actually draw from the study. Now that we have our data collected, we can start to think about how we actually want to model the relationship between our explanatory variables and our outcome. Now, I don't want to get bogged down in exactly what these methods are doing, but I think this is a good reference for you later on as we move throughout the semester in order for you to kind of classify or categorize the different approaches that we're taking. The one thing that I would stress right now is that, as you can see, there are many different types of variables that we're going to become familiar with. And that includes discrete variables that take on single or multiple categories, as well as continuous variables that take on many values. Now that we have our model in which we have a certain set of explanatory variables and an outcome variable, we need to think about how we're actually going to go about fitting that model. Now, we're going to spend a lot of time talking about why it's most common for us to use a least squares estimation technique. Later in the semester, we'll begin to slightly talk about why we may be interested in using maximum likelihood estimation. Then we'll have to move on to the sixth step, which includes validating our model, making sure that we actually meet the required assumptions in order to have a valid model of the relationship between X and Y. Seventh, we're going to have to assess the goodness of fit from our model. And last, we'll spend a lot of time talking about how to discuss the results and interpret the estimates that we receive from whatever model we're conducting. I want to conclude talking about the techniques that you'll learn by honing in on the exact skills that you're going to be able to take away from these various steps. So by the end of the course, you should be able to examine and transform data that you receive. You should be able to diagnose influential data. And trust me, you'll understand what a lot of these terms mean by the end of the semester, but you'll have to understand what influential data is and understand what collinearity is. You'll also be expected to identify the appropriate statistical models when you're presented with new data. So that's going to be exactly what you're asked to do during exams. And you're going to be asked to perform real data analysis with R and interpret these statistical analyses. And I want to stress that that is a really important skill that I want you to walk away with from this semester.